Assalamualaikum and good morning. Today we would like to present our material testing and fracture analysis assignment in non-destructive testing. Our assignment require to use non-destructive testing. Non-destructive testing is testing the specimen or workpiece without destroy it. There are two types of defects in non-destructive testing: surface defect and internal defect. For surface defect, we have visual testing, dye penetrant testing, and magnetic particle testing. While internal defect, we have radiography testing, ultrasonic testing, and eddy current testing. Among the non-destructive testing, we decided to choose dye penetrant due to the limited resource. Because dye penetrant is affordable compared to the other non-destructive testing. Potential defects that can be found in this testing is crack, porosity, and blowholes.
A very good day to everyone. Okay, in this video today I'm going to show you conceptual dye penetration testing. Conceptual dye penetration testing. This idea inspired from dye penetration inspection. There are 6 steps in dye penetrating testing. Okay, first, pre-cleaning the workpiece. Second is applying penetrant. Third is after applying the penetrant, remove the penetrant. Next, applying the developer. Next, the evaluation process, and finally, post-cleaning process. In this conceptual dye penetration testing, we are using this part as a workpiece. This is bicycle's double stand. As you can see, this particular part is bent. So we are going to do inspection on this part to find the defect. Because of we doing conceptual dye penetration testing at home, so we are using similar items that could match with item used in dye penetration inspection. Now I will show you the preparation item. This is the preparation for this experiment. Workpiece, spanner to open the workpiece. We have some soapy water. We have rush penetration. We have thinner. We have spray. We have some clean clothes. And finally, we have a glass for safety purposes.
Okay, so now we're going to our next part, which is analysis of defect. So from this slide we can see there is a picture of our part, and from that we can identify it is a failure which is called as a crack initiation. So crack initiation is a first stage of the fatigue failure. So fatigue cracks almost always initiate at a free surface and near a stress nozzle. The initial development of a fatigue crack occurs at localized discontinuities in the metal's crystal structure. The generation and movement of discontinuities strengthen the metal through plastic deformation. This phenomenon is called work hardening. So as we know, as the metal becomes work hardened, it loses its ability to plastically deform in the localized area, where cyclic stress and evident. Once the metal reaches the plastic deformation limit, the discontinuity becomes more cracked. So this is the details about crack initiation. Now we move to our next slide, which is our stage 2. Okay, now we move to our second stage, which is called as crack propagation. So crack propagation is a crack which once a crack is initiated, its continued cyclical stresses repeated the process, slowly moving a micro crack, which becomes a threat to structural integrity. So micro crack is, you can see in the picture, a yellow line. The yellow line which indicates the liquid we use to define or identify the defect. So this is our assignment, which was completed by identifying a defect in a part which we were chosen. So our objective is achieved. Thank you.